Okay, welcome back everyone. So we will continue from our series from where I stopped in the last video. Now we'll go over to what we call the visible image formation. Now this is now the second aspect. Remember in the first lesson I told you guys about what latent image formation. That is all about what latent image formation. That is when image that you cannot see is what's being formed on the screen, the processes that take place. And I hope you guys understood that aspect. Now we move over to the next aspect, which is what visible image formation. This is now where the main image is being formed. Now, what is visible image? This is what image that is then formed after what the process of what development, that is the film processing what steps. That is after you have finished what processing your film, the image, the visible image, the image you can now see. That is what we will call what visible image. That's what I'm trying to say now. Now we have what stages of what visible image formation. Do you understand? Now we have what the first main stages are what the development, the developer, the rinse, the fix, and the wash. But remember, if you look at here now, I divided it into two because what we have what manual processing and we have what automatic what processing. The manual processing and the automatic processing are not really the same thing. They have this, they use the same film and cassettes because it's film cassettes method. But when it comes to the film processing, it's different. Manual, we make use of what processing tanks, which consists of what various what chemicals. We will not go deep into that. When you enter 400 level, you move deeper into these things. But I want to give you a shallow foundation so that during your exams, they might actually go over that what they did to us though. When we wrote our exams, they didn't teach us this thing, but they ended up setting these things for us and it threw us off balance. So I will just give you guys a kind of the knowledge you will need so that in case it happens in your time, you can be able to through that questions. When you enter 400 level, you go deeper into it. You understand? Now, we have the manual processing, which is processing what tanks, and we have the automatic processor. That one is now the machine that processes these things for you. You don't do it again. You don't use film anger to start putting in. You wait for 5 minutes, put away. No, this one now is now automatic. Now, in the manual, we have the developer, we have the rinse, we have the fix and the wash. This is what for manual. But here we have the automatic, which is the developer, the fixer, the wash, and the drying. Do you understand what I said? It does not have rinse. Do you understand what I said? So remember, be careful of this thing because BJ, it can fuck you up. Now they will ask you what are the stages of film processing in an automatic processor. Please note that this one is for manual development, rinse, fix, and wash. But here there is no rinse again in automatic processor. It is now development, fixing, washing, and drying. This is the 4. Do you understand now? So be careful so that you will not go and displace and throw what you are meant to know here off balance. That's what I'm trying to say. Now that is that for it. Now let's go over to what we call the developments. This is the first step. Now I will not write down anything for you guys. All these things are here. So when I give you guys a note, you can just note it down. But for me, I'll just be calling and explaining for you guys. The explanation is the main thing. Later you can write down the notes, but for now, understand what I'm trying to say now. This place, you need to give me full attention. Now, when we come about, development occurs when the film is placed in a developer solution. The developer solution contains a reducing agent which donates electron to the development center, that is the sensitivity spec. These electrons completely reduce the exposed silver halide grains to black metallic silver and amplifies the clumps of the metallic silver. Now, remember, let's go over to this place now. Let's say that this is the. Now, these are, let's say that, remember, in the initial one, the end product was what? There was what? Chromes of metallic silver. There are chromes of metallic silver that were formed in this film. Now, let's imagine that this one was, let's say now this is a film, and let's just craft out one example. Now, this is a chrome of metallic silver. Do you understand? Now, this clump of metallic silver, what this developer solution does is it has a chemical. This development solution has the various chemicals. I will list them, but the main chemical is the releasing agent. It's called the phenidone hydroquinone. Please take note. Phenidone hydroquinone. This will phenidone hydroquinone. they will ask you this thing, a must. Sorry about my handwriting, just the board. Just keep going. Phenidone hydroquinone. They will ask, this is the main reducing agent used. This is two different chemicals on this one, but it has what we call super additivity in such a way that you can't do without this one and you can't do without this one. They are both combined to give you a good developer solution. Do you understand? Now, this phenidone hydroquinone, it donates excess electron to this sensitivity spec. Let me now call it the development center. It donates excess electrons here. And what is the outcome of these excess electrons? It then amplifies this thing now. You know, remember, there are small, tiny clumps. But when this thing acts on it, it then makes it what? To become what? Large clumps. It becomes what? Large clumps of metallic silver. Do you understand? It becomes so large. Do you see where the image now starts forming now? That tiny image that you cannot see starts becoming visible. The clumps what? Begins to what? Increase. That is what this is the main component of the developer solution. Is the what? The reducing agent, which is what? Phenidone what? Hydroquinone. This is what it acts in this specific spec and makes what developing what center what large enough. Start amplifying the image. Do you understand? Now, let's go over here now. Take notes of bromine ion charges, barriers which are broken when exposed to photons. This brings about what the selectivity of what the developer. Now, we are talking about what the selectivity of the developer. I want to someone ask me a question. Why is it that it will only act on this place, but there are other members? When I'm being exposed to radiation, let me say I'm doing an X-ray examination, I'm exposed to radiation. Remember, it's not all part of the film that will absorb this photon. Do you know? It is not all part of the film that will form this development center. There are some that don't receive photons that will just appear black. Now, how do you think that when you place the film inside the developer solution, how do you think it can select? How does it know the one that it will go and react? How does it know the development center? Or is it magic that it just enter and just start spotting those places? There is something that happens that prevents it from reacting with those places that did not receive photon at all. If it's not like that, means when you just expose and place it will just develop everything, and image will appear on every aspect of the film, which you know is not actually nice or good. What happens is that that's what we call bromine charge barriers. Now, these bromine charge barriers are everywhere around the film. But when these photons in that first reaction that occurred react with this the film, now it will break off those bromine charge barriers in those particular aspects of the film that it's made contact with, it reacted with. But those places that it did not react to, that is part of the film where the photon did not pass through, will kind of retain it was bromine charge barriers. It will not break it off. Do you understand? Now, those retainment of those bromine charge barriers will now, this phenidone hydroquinone, will now select those places where there was what, because if there is a bromine charge barrier in a particular place, this phenidone hydroquinone cannot act on it. It can't. That is why anywhere that radiation, like anywhere that there is no body part, that's why if you see a film, the only part of that image appears on, there are some places where the image appears on, while there are some places that are just black like that, it will not react anything. What's happened is that this stuff, phenidone hydroquinone, was selective. It selected the parts where the bromine charge barriers were broken. And those that those places that the bromine charge barriers were still intact did not react, whereby it remains normal. It remains black, it did not change. You see now, this is how this phenidone hydroquinone was selectively picks the part where it will develop, and the part that it will not develop, it just leave it. That is how the selectivity occurs. Do you understand now? Now, we now talk about what constituents of a developer solution. First of all, we have a developing agent. Now, this developing agent is what we call I've said it before. The phenidone hydroquinone. Let's see what we have here. A reducing agent. This donates electrons to the development center, reduces the invisible silver halides to visible metallic silver. The most used developing agent is called the phenidone hydroquinone. Do you see it now? I told you that this is super additivity. It's super additive. These are two different chemicals that must be used together. You can't separate them. it must be used what together for it to get what the tangible result was made. You understand? Now, the second one is what's called the what solvent. Now, this solvent is what mostly what water. Now, let's say it serves as a carrying medium for other constituents of the what developer solution. Also softens the gelatin, allowing other constituents to what enter easily. The most common is what water. In fact, water is the only solvent we use here. Now, what does water serve? It just serves as a medium for all the words, because remember, this developer solution has many components inside. Do you understand? It has many components what's inside of it. So now this solvent acts like, you know, water. Now when you use water, you maybe let's say now you are doing something. Which example will I use now? Let me say you are making tea now. You put milk, all those things. This is how this thing happens. It serves as a medium. You understand what I'm trying to say? Now this solvent also softens the gelatin. Do you understand now? You remember the gelatin? I told you something about the gelatin in my first video. That this gelatin just like it just serves as a barrier where these silver halide crystals are being embedded. Remember, these things are crystals. So just like how I put it now, I don't know, most of you that did mosaic in school, you know that sometimes if you want to do a design, I want to use bead, you just put gum on that surface, and now put the beads on it. What happens when you put those beads? It will clump together to the cardboard sheet, or for those that did it, like me, I did it, you understand? And when it start clumping, before you know it, it will start forming what exactly that's how this thing happens here. Those silver halide, this gelatin acts like the surface barrier that holds these things intact. Do you understand what I'm trying to say now? So that this solvent also softens those gelatin so that the developer solution can be able to penetrate easily and react with the emulsion layer of the film. If not, the reaction will be the image will not be that visible, or it will be blurred. Do you understand? So that's it. Now we have the third one is the restrainer. Now we have the restrainer. Now the restrainer helps to prevent phenidone hydroquinone from acting on unexposed silver halide grains, thus preventing chemical fogging. This is done by placing extra bromine charge barriers around the exposed grains. What do I mean? The restrainer helps to prevent phenidone hydroquinone from acting on unexposed silver halide grains. Now, remember I told you something about this. The restrainer, when I was talking about phenidone hydroquinone, I told you that the reason why phenidone and hydroquinone is very selective is because of these bromine charge barriers. When there is a bromine charge barrier, phenidone hydroquinone will not react. Do you understand? Now this is what happens. Now, when there is when the restrainer phenidone hydroquinone from acting on unexposed silver halides, thus preventing chemical fogging. So you understand what I'm saying now? Now this restrainer, I told you about bromine ion charges. Now this bromine ion, I told you that for phenidone hydroquinone to be selective, there must this bromine ion charge barriers that will tell you that this place was not being exposed to photons, so there's no need for it to react on me. Then all those places that was gotten rid of bromine ion charge barriers, the phenidone will now know, okay, this is the place where there was photon interaction, and this is where my work is. So it will leave this place that did not receive any photon reaction and go and act on this. Now, this restrainer, what it does is that this restrainer will come and creates more bromine ion charge barriers. It kind of intensifies it in this place. It creates this more bromine charge barriers in such a way that it will enable the selectivity to work more perfect. It has already been selective, but it just accelerates the selectivity, like makes it more suitable, so that the film will develop properly. Do you understand what I'm trying to say? Now, example of restrainers are potassium. Remember, restrainer, if I forget, restrainer is also called an antifoggant. Now, I don't know, many of you know what is fogging. I don't know how many of you know, but I know all of you have heard about it, but you will hear, but you don't know about it. It's normal. Now, what is fogging? Fogging is an undesirable exposure of a film towards radiation. Do you understand? Now, imagine if I bring a film now. Remember, films are not meant to actually meant to be kept from light, because once a film interacts with light, it becomes fogged. Now, what is that? Fog is an undesirable exposure of a film towards radiation or any light source. Now, when a film is being exposed, it becomes fogged. it will just react and become white, and after that film becomes useless. Now that is what is happening here. If there is this, the strainer is not there, this phenidylhydroquinone will go and be reacting on the places that is not meant to react, where image is not meant to be formed. It will go and be reacting there, and thereby it will now fog those areas. That is why when you bring a film now and look at it, you will see the place where the image is formed. And for you to know that that chemical developer solution is not good, those areas where the image was not formed will also be shining white or shine another color, meaning that actually this phenidylhydroquinone not only reacted with what the sensitivity spec or the developing center, also reacted with other places that were not being exposed to what photon. That is what we will now call it was that film was already fogged because of what maybe the restrainer is lacking. You understand? Now, example of a restrainer here is what? Potassium what? Bromide. Bromide. Please don't worry about the writing and everything. I will still give you guys note on this. Now, potassium or bromide is an example of it. You see the bromine here. Now, this bromine is what supplying what more what negative or charge barrier. Remember, this bromine is negative. It will keep what supplying bromine to this, thereby what increasing what preventing anti-fogging and also increasing the charge barrier, thereby improving the selectivity of this phenidylhydroquinone. Do you understand what I'm trying to say now? So now we go back to the fourth one is what the accelerator. The accelerator is the fourth one. Please take note of all these things. Now, what do we have here? Now, gives the developer solution a pH of 9.8 to 11.4. This alkalinity is required for the phenidylhydroquinone to function. Now, example of the accelerator is what? Potassium bromide. Please, I want you to take note of two things. The example of this accelerator and the pH. Now, the pH, let's say that, okay, potassium carbonate is the example of this. Is the example of this what accelerator is what potassium what carbonate is the example of this accelerator. And now they say the pH is ranging from what? Remember, it varies. So please take note of the one the lecturer will give you. Is 9.8 to 11.4. Is the pH. Remember, now I forgot to tell you something before we begin. Now, developer solution works better in an alkaline environment. Please take note of this. The alkalinity, the developer solution, it only works when the environment is alkaline. The moment it becomes acidic, this developing solution will cease to function. It works better in an alkaline environment, whereby the fixer solution is what? Acidic. Please, they will ask you this question. The fixer solution is what? Acidic. The developer solution is what? Alkaline. The range varies. It depends on the one lecturer will give you. So whatever the one lecturer will give you, just let his own. Do you understand? But it will still fall within this range. But what you just know is that it was alkaline, the other one is what? Acidic. Now, the example of an accelerator is what? Potassium carbonate. Now, what does this accelerator do? It just helps to maintain the pH of this environment. Because you know that, you remember, when the pH of a particular medium is distorted, you see that the reaction will no more go like as planned, it will not go well again. The pH has to be normal. You understand? The pH has to be within a normal range for what that reaction to what take place. Now, that is why we call what pH what 9.8 is helps to maintain the pH of this solution. Do you understand? So that the phenidylhydroquinone will what react what well. Now, whenever the pH of this is altered, it means that what this solution is already weak, and if you keep using it, you will not get a good developer. Like the film will not develop properly. Do you understand what I'm trying to say? Now, this is for it. Then we go over to our friend here. So now the fifth one is what we call the what? The preservative. Preservative. Now, a preservative you can use here, you divide, but the main one we normally use is what? Potassium sulfite. You understand? So this is one. This, sorry for this. This is 2. This is 3. This is 4. Now this is the fifth one. Potassium sulfite. Now, what does this do? Extends the usability of the phenidylhydroquinone by preventing area oxidation. Now, let me not go too deep to this area oxidation of this stuff. It's not for your level now, but I will just give you a bit hint of it. Now, this sulfite, now potassium preservative, it helps to extend the shelf life of this developer solution. Now, this developer solution actually is susceptible to area oxidation. What is the meaning of area oxidation? Oxidation that occurs in the environment. Remember, our environment is made up of what? Oxygen. And this oxygen can what? Is able to oxidize. Like it can oxidize, especially when there is a reaction going on in a particular place. If that reaction maybe is not closed or something like that, it is not a closed reaction, it is subtle to what? Area what? Oxidation. Do you understand? Now that is where this thing comes in. What does this do? It helps to prevent that area oxidation from occurring, because if this oxidation occurs, it usually forms it kind of forms a reaction called sulfite or sulfonate, something like that, but it's not, you don't need to put your hand. But what I would advise you to know that this preservative is what just helps to prevent what area what oxidation from occurring, because when it occurs, it kind of affects the film. That is why if you look at the film, it will be shining kind of, if you change color, not actually pinkish. You know how whenever sulfur reacts to something, you see that it's always shines something like pinkish or reddish, something like that. You will know it. So you will not know that this solution is susceptible towards area oxidation in water. That is why you have to put the preservative, potassium or sulfite. You understand what I'm trying to say now? So that does it. So we go over towards the sixth one. So we said that this preservative prevents area oxidation. Now the sixth one is now what we call the buffer. Now this buffer, it doesn't do much. It's just the same thing with what the accelerator does. Now what this buffer does is it maintains the alkaline pH provided by the accelerator. Now remember, this accelerator provides a pH of this medium 9.8 to 11.4. Do you get? It provides a pH of this 9.8 to 11.4. Now, what this buffer does is to maintain that pH. When you say that maintenance, it will just maintain the pH. Do you understand what I'm trying to say now? So the pH now will fall from 9.8 to 11.4. It just gives it that maintenance. Do you get? Now that is just it now. Now, example of a pH here is what we call what? You can use any example, but most of the time it's called the what? You just know that the buffer kind of maintains the alkaline solution of the accelerator. Now we move over to hardener. Now what does this hardener do? Prevent excessive swelling of the emulsion layer. It prevents excessive swelling of the emulsion layer. Now what does this emulsion layer now? See, we have this emulsion layer is where the reaction takes place. Remember, this emulsion layer is where the selectivity and everything takes place. Now, this emulsion layer is susceptible to it might swell. Remember, there is a solvent in the water. Like there is a solvent there. Now, when you place the film for a long time, it can swell. You get? Especially when it may not affect much in manual processing, but in automatic processor it will affect, because if you have seen automatic processor before, it's normally when you place the film and the film is moving through the rollers. If the film is like it was much, it will hang in the automatic processor because the film now have increased in size and it cannot be able to pass through that roller again. Do you understand? Now that is why this hardener is needed. Is needed. Example of this hardener is what we call the glutaraldehyde. The glutaraldehyde. This is an example of a hardener. Do you understand what I'm saying? What this glutaraldehyde does is that it helps to harden this emulsion layer. It prevents it from overswelling. You get it will swell, but let it not swell and leave its normal size. Do you understand what I'm saying? So that is what this hardener does. Now, the last one is what we call the sequestering agent. This sequestering agent also does the same thing. That now it prevents precipitation of salts on the emulsion due to byproducts of the developer solution. Example of this is EDTA. Now we say the sequestering agent. Example was the EDTA. Now the meaning of this EDTA is what? We have ethylene diamine triacetic acid. Let me write it. Ethylene diamine tetraacetic acid. Now this is an example of what the was sequestering agents, ethylene diamine tetraacetic acid. Now what this sequestering agent does is helps to prevent byproduct of salt. You get, when this reaction is taking place, there are some salt products that are formed as a byproduct. Remember, in every reaction, there is a byproduct. Now, the salts, like the salts that are formed afterwards, reaction of the developer was solution or the development agent, kind of, this salt is, if you leave it in the film, it forms what colored products. Salts are colored. It forms colored products, and you see it on the film. So what this sequestration agent does is what this EDTA helps to prevent it. Do you understand? So you see that all the components here now play a role one way or the other. These are the 8 main components of the developer solution. Now this has to work hand in hand for a good developer development working on the film. It must have to work hand in hand. Without that, there will not be any proper development of the film. Do you get now? So that is all for the developer solution. Now we move over to the fixer solution. Sorry, I will clean this, and I also clean this. Now we move over to the fixer solution. Now we are done with the developer solution. Now remember, I told you that this fixer solution is acidic. It works in an acidic environment. Now, what does this fixer solution do? Let me just give you the main function of this fixer solution. It does not do any much deal. Most of the deal that is being done is done in the developer solution. Most of the, in fact, once you are done with development, the fixer, everything it does is just from the name, fix it, just fix the image and makes it permanent on the film. Do you understand? It doesn't do much. It just kind of ensures that this image that was formed in the developing solution is now fixed permanently on the film. Do you know what I'm trying to say? Now, in the fixer solution, we have let's see what's here. Fixer solution helps to get rid of unexposed silver halide grain by dissolving them out of the solution and fixing the image from the developer solution permanently on the film. Now, what does it mean? Now, this fixer solution also gets rid of silver halide. Now, this excessive silver halide grain that was not exposed. Remember, I told you that when this image now, remember, after the development, there are many clumps. Let's say now this is just a film, and there are many clumps now that are formed. But remember, these clumps that are formed now, there are some parts that were not silver halide now that did not take part in the exposure. There are some that were not exposed to photons. And if you keep leaving it there, if you leave this thing here, what it means is that when you go and bring out this film and expose it to light again, these things will react and cause fogging. Do you understand what I'm saying now? It will go and react because they are still sensitive. They have not received anything, but they might still receive. Now, what this thing will do is that it will now come and wash off these unexposed silvers. Those ones that have not been exposed, they will just wash all of them off the film. Do you get? And leave it pure, turn it to pure black. That's why if you bring out your film, the areas that are exposed are white. While the areas that are not exposed are black. That is what this fixer solution does. And it will now make these clumps or something like that. These are now the main images that are formed. You should now fix it permanently on this film. Do you get? That is what this one does. Now we move over to, let's list the functions of the fixer solution we have here. 1, it stops the activity of the developer. That is the main function. 1. 2, it clears the film from unexposed silver halide, which I explained now. 3, renders the image chemically stable. The same thing. When these things are removed, it now becomes chemically stable in such a way that if you bring it out and expose it to light, it will no more react again. Do you understand what I'm trying to say? That it becomes stable and intact. And 4, it completes the process of hardening. You get? Now remember, we had the hardener in the developer solution, if you could remember, which was neutralizing hide. This one also has a hardener on this zone. You get? It also kind of hardens the film because when you bring out this film from the developer solution, the film is also kind of it's all weak already. So you have this hardener also helps. The hardener in this fixer solution also helps to make the film firm and strong. You get? Now we talk about, let's go to constituents of the fixer solution. Now, constituents of the fixer solution. Now we have the fixing agents. I'll just write them down and we'll now start explaining. Example of the fixing agent here is what? Ammonium thiosulfate. Please, you guys should actually take note of these things. This fixing agent and the examples. This is what will always be coming out in the exam. The fixing agent, what is the fixing agent used in fixing agents? It is what? Ammonium or thiosulfate. Now, dissolved unexposed silver halides. Dissolved unexposed what? Silver what? Halides. This makes the image chemically what? Stable. Now, what this thing does, this ammonium sulfate does is that what? This removal of silver halides, unexposed silver halides, is done mainly by this ammonium what? Thiosulfate. This is what makes this thing happens. It will dissolve the what? Unexposed what? Silver halides. It dissolves them, and now what? Makes it what? Chemically what? Stable. In such a way that this film will no more react to anything. Like, it's no more, you expose it to light again, it will not react. Do you understand? Because those unexposed silver halides that are still susceptible for reaction has been what? Removed from the film. You get? And remember, I told you that this works well in what? In an acidic environment. This ammonium thiosulfate works now in an acidic environment. That is where it works better. Do you understand? This is where it works better. Now, we go over to the next one. Solvent. The material is what? Solvent. We all know that solvent is what? Water. This is just a medium whereby other chemicals are being embedded into the solution. Now, the third one is what? Acid. Acid. This is what I remember. I told you this acid is what makes the environment of the solution acidic. It works better in an acid environment. Now, provides a pH of 4.0 to 4.5. This acidity stops the action of the developer. This activity is also required for the fixer solution hardener. The example of the acid used is example acetic acid. Now, what are we trying to say here? This acid, what it does is it stops the action of the developer. How? You guys don't ask me how. Now, what happens is that this acetic acid now, this developer solution is working in an alkaline environment. If I remember, if I told you, the range was 9.5 to 11.4, if I remember. Now, this acetic acid, which works well in an acidic environment of 4.5, let's just say 4.5, let's not give the range. Now, this acetic acid, now, it stops the action of this developer. Because remember, the developer, when you remove it from the development reaction, if it was a manual processor, you put it in rinse. But in a situation where there is an automatic processor, they don't have rinse. This developer solution will usually enter the fixer solution. Now, what does this thing do? This acetic acid is what stops the action of the developer. Because the developer will not work in an acidic environment. It can't. So this will stop it with this acidic environment it was producing. Do you understand what I'm trying to say? Now, this is what the function of this acetic acid does. And it also produces a medium for this ammonium thiosulfate to react. Do you understand? Now, we have another one called the preservative. Now, the preservative here is sodium sulfite. Sodium sulfite. This is the main preservative here. Please take note. Remember, the preservative here and one in the developer solution is different, so that you're not going to misplace them. Now, an example of this preservative here is sodium sulfite. Now, what this preservative does? Now, it delays the onset of sulfurization. It delays the onset of sulfurization. Remember, I said something about sulfurization in the initial one. Now, what this one does is, remember, this sulfurization occurs when there is a reaction occurring here in this fixing agent. Remember, that is what we call ammonium thiosulfate. This ammonium thiosulfate that is here. Remember, when it's reacting, there is a byproduct. I don't want to write the equation for you guys now, but there is a byproduct of sulfur that comes from here in this ammonium thiosulfate. There is a byproduct of sulfur that is here. Now, this byproduct of sulfur, it clumps together and form what we call sulfonates. Let me write it here. Sulfonates. Sulfonates. This is the byproduct. It forms sulfonates. Now, preservatives, example, sodium sulfite. Now, what this thing does is that it prevents this formation of this sulfurization from occurring. This process is called sulfurization. Because if it occurs, it affects the film. Do you understand? It also affects the film. Now, this preservative will just come and acts on this byproduct of sulfur. You get, so that it will not accumulate in the solution and kind of reduce the quality of the image that was formed. You get. So we have another one that is called The another one listed is what's called the hardener. Now the hardener here is what we call what aluminium chloride. This system might vary. You get just the hardener here do vary. The one that might be in your lecturer's notes might be different from this one. But what I have here, what I'm using here is aluminium chloride. Your lecturer might say another one. Do you understand? But this one, aluminium chloride, is the one I know. The hardener that is here. Now, what does this hardener do? It increases the shelf life of the radiograph by making the surface more scratch resistant. You get the same thing that the hardener in the other one was glue to aldehyde. Please don't misplace them. If they ask you what is the hardener is in fixing agent, please don't go like glue to aldehyde. Tell them it is what aluminium chloride or whatever the one the lecturer gives you. But the one here is what aluminium chloride. The one for the developer is what the glue to aldehyde. Now this aluminium chloride, remember I told you that what it makes the film more resistant to scratches. Remember what makes a film quality and makes its shelf life last long is the way the film. You know, when the film is produced, you handle it around, you carry it around, kind of things. There are some films that if this thing is not sufficient, before you know it, it will start tearing from the base. You understand? Start tearing from the base and start entering the other layers of the film. But if the film is strong, you see that this hardener is active there, the film will last for long. It can last for a very, very long time. You understand? So that is what this aluminium chloride does in the fixing agent. And we have the last but not least, we have the anti-sludge agent. The anti-sludge agent. Now, example of this anti-sludge agent is what? Example is what? Boric acid. This one is not actually prominent. It depends on what the lecturer. Some add these things, some not add it, but it's actually required here. What does anti-sludge agent do? Now, this prevents precipitation of sludge, that is byproduct of the hardener that can stain the film. Now, this aluminium chloride also have what produces what byproduct. Do you understand? Byproducts of chloride, any of them, these byproducts can what stain the film. All these chemicals have byproducts, and these byproducts can affect the film in one way or the other. In addition, that it's providing something for the film, but it can also produce what byproducts, which you know that all chemical reaction does. Every chemical reaction produces what is byproduct. Now, this anti-sludge agent, boric acid, acts on the byproduct of what this hardener. Whatever byproduct that this hardener is producing, this boric acid was counteracts it, so that the products will not affect the film. And what this product does is that most of them stains the film. That's what it does. It stains the film or make the chemical less inactive or less active. It makes it less active. Do you understand? Now, these are the 7 main constraints of the fixer solution. We have the fixing agents, we have the solvent. Remember, this solvent is example is always water. Please, nothing else. It's always water. Then we have the acid. We have the preservative, the hardener, and the anti-sludge agents. You get? Please, these are, sorry for that. This is 4, 5, and 6. Sorry for that. So there was 6 main of them. You get? So depending on your lecture might decide to add other ones, but these are the 6 main standard ones that we know. You get? So the last one we now have. I will clean this. Sorry. I want to clean this, and the next one was the wash. Now, the washing, after fixing, you wash the film to get rid of the product of the fixing solution. Now, remember I told you in the steps after the fixing. Remember, after development, I didn't talk about the rinse. The rinse, I don't talk much about that. Rinse is just water, just to rinse it. But in automatic processes, remember, we don't do rinse. Don't forget, we don't do rinse in automatic. You just take it over to the fixer solution. Do you understand? Now, the next one after fixing is washing. Here, you wash it, same thing in water. Just remove the byproducts of the fixer solution, because the fixer solutions are still there. And if you leave them there, it keeps acting, and before you know it, it might affect the film in one way or the other. So what this washing does is just remove the byproduct of this fixer solution. Is mostly water. A component of this is mostly water. So what it does just to remove the excess, this fixer solution, the product of this fixer solution, just removes them. You get that? Was it. Now we move over to the drying. Now remember, this drying is both. Let me explain something for you. Now remember, I told you that because it does not mean because I don't add drying in that manual processing, does not mean that manual processing does not do drying. Just that the drying in manual process is the one, you just bring it out and just spray it on the sun drying, all those things. But this automatic processor does the drying by itself. If you remember, some of you guys I took to the demonstration room, I showed you guys the automatic dryer. This is what happens there. It dries the film. You get? So this drying is just what, after putting this in water to remove the components of this solution, you put it, you just dry the film, and everything becomes a flat, and your images were being produced. You understand? So that is the last of this. Now, I want to do something for you. Factors that affect what development and what fixer. Now, what are the factors that affect this developer and fixer solution? Now, there are mainly three of them. We have the what? Temperature. We have the two. We have the time. And we have the what? Constituents of the solution. What do I say? Factors that affect the developer and fixer solution. We have the temperature, we have the time, and we have the constituents of the solution. Now, what am I saying? Now, I'm not saying that these are the only factors. Please, these factors are up to 10 or 9, but these are the three main ones. The three main ones are these ones. Other ones are just added. Now, let me explain. When I talk about factors affecting these things, these are the things that should be kept intact for what a developer and fixer solution to what function or properly. One, the temperature. If the temperature is not stable, if the temperature is too high, please take note. If the temperature is too high, the solution will become what? Overactive. Let me say in the developer now, if the temperature of the developer solution is high, there will be overdevelopment of the film. Please take note of this. It's an example question. I'm asking now, what occurs, what happens if there is increase in temperature? The various emotion, overdevelopment, underdevelopment, and so on. Please, when there is increase in temperature, there is increased activity of both the developer and the fixer solution, thereby leading to what? Overdevelopment or what? Overfixing. Do you understand what I'm saying now? That is for temperature. But if there is decrease in temperature below normal, there will be what? Underdevelopment or underfixing of what? The film. Do you get? So you see how the temperature affects now. So the temperature has to be maintained within a what? Normal range for this what to occur. You understand? It must have a normal range for this what? So this solution, this reaction to what occur or properly, and for the film to what be produced, the image should be produced on the film. Now, the second one is time. Now, this time affects. Now, if this time, the time, let's say in the development, the minimum amount of time it takes for manual processing is 5 minutes in each of them, 3 to 5 minutes. Now, if you exceed that 5 minutes, guess what will occur? What do you think will occur? The film will remain there, and what overdevelopment will start happening because it is exceeding the normal range. So the time also was affected. So if there is increased time, there will be what? Overdevelopment of the film. And if there is decreased time, there will be what? Underdevelopment of the film. So as what? Fixing. Do you understand? If there is increased time, there will be overfixing. And if there is decrease, there will be what? Underfixing. Now, the third one is what? Constraint of the solution, which you know is obvious. If the constraint of my solution, maybe they are not complete. Let's say, okay, in the developer, we have up to what? 8 constraints. If, let me say, I have out of the 8, I have 5. Or maybe 8 of themselves, they are not really stable or the concentration is low. Okay, I want to add what? Concentration. Let me just add this one. I do remember that I have to 10, but let me just add this one also because the other ones. Now, if the constituents of the solution they are not complete, or 1 or 2 is lacking, or let me say you don't use the fair not high local that is super additive, you just use the one, you see that the quality of your film will be reduced. You get? So you see that they have to be complete, your constituents have to be complete and was in both amount and ratio for what this development and fixing to what occur or properly. You get? Now we talk about the what concentration of the solution. Now, if the concentration is high, you know what will happen. There will be what? Overdevelopment and overfixing. But if the concentration is lower, you see that will be underfixing and underdevelopment. So you see that all these factors plus other ones also have to be kept intact in a normal range for this thing to what happen, for this the fixing and the development will happen what properly. Do you understand? So that's just all about this thing. Don't in other when you keep advancing, you start seeing how the equation, you might be using the equation to see how most of these factors will affect what the film. You know what I'm trying to say? So for now, I just gave you guys a brief, like, this is what you need for now. Let's not advance when you don't need that for now. So, and trust me, this I explained now is, in fact, that will be all you will need. Even in your 400 and advancing to 500, this is the basics. They won't even go further than this because most of these methods now are archaic. They are no more in use again. In fact, it's only in the African countries that you still see this. If you go abroad, they don't even know what that this is still exists. Do you understand? So that is all for today. So thank you very much for listening to me. I appreciate you a lot for those that actually followed me through. Because I know that this class actually will help and it's very, very self-explanatory. So whatever question you have, my DM is always free, or you can actually maybe in the comment section at the rest, you can just drop your questions there and I'll attend to you. Maybe by 2 days from now, I will drop the notes for you guys in the group. So thank you very much for listening and wish you guys